Okay, today we're going to work on Lewis dot. Basically what Lewis dot is identifying the element with the symbol and the number of valence electrons. What you're going to want to do is pull up the periodic table that has the column of electrons in each box, and that last number is always the number of valence electrons. So if I take the symbol for hydrogen, I'm going to do the capital H. And then I see that there's only one valence electron, so I put one dot. If I do something like helium, its symbol is He, and there are two dots. I put one there and one there. We always go around one at a time on each side. If I do boron, boron is a capital B. There's three. I'm going to put one at the top, one at a side, one at the bottom. If I do carbon, it's a capital C, one at the top and one on each side. That means it has half the valence electrons to fill an octet. When you have fewer than 4 valence electrons, you're very unstable and you're going to do everything possible to get rid of those valence electrons so you have empty space in your outermost energy level, which is why metals give up their electrons. Now, if you notice nitrogen, okay, I'm going to go to another page here. If I do nitrogen, it's a capital N, and there are 5 valence electrons. So I'm going to put one around on each side, and then I need to show the 5th one, which makes something called a lone pair. That means there are 2 valence electrons in that orbital area. That's the maximum you can have in an orbital area. Okay, and the goal is to get a total of 8, or to combine in a compound to make a total of 8 to be the most stable. Oxygen, capital O, it has 6 valence electrons, so you notice I go around 1, 2, 3, 4. Then I'm going to show 5, and I'm going to show 6. Notice that the 2 lone pairs are on the 2 sides here, one here and one here. Those lone pairs are going to have an extra pole, and that's why oxygen has some polarity to it, which we'll talk about with our covalent bonds. Then we have fluorine, capital F. It's going to be 1, 2, 3, 4, 5, 6, 7. Again, very close, but it needs that one last valence electron in this spot to be stable. So it's really willing to take whatever it can, which makes it the most electronegative element on the periodic table. And to fill out that whole row there, neon has 8. 1, 2, 3, 4, 5, 6, 7, 8. Notice it's 2 on each side. We don't make a circle. Neon is a noble gas. It has its outermost energy level completely full, called an octet, O-C-T-E-T. Because it's stable, it's not going to interact with other elements to make compounds. So the noble gases do not make compounds. That's our group 18. You're going to practice your Lewis dot with the worksheet. Hopefully this will help you figure out how to do it. Use that white periodic table. Look at the lowest number in the column. That's the number of valence electrons. Have a great day.